Welcome to Control Systems N6. Today's presentation is going to be on Nichols chart. This is the module that comes immediately after body diagrams. So if you haven't watched my presentation on body diagrams, I will advise you to do that. The reason being that in that video, I lay down all the foundation that you need to be able to understand all of these modules. So if you've watched that video, then this module is going to be easy for you to understand. Having said that, let's begin. So first, what is Nichols chart? Basically, it is also a frequency response technique of analysis that can enable us to determine the stability of a control system. So basically, really, what is happening is that we are trying to achieve the same thing that we achieved with body diagrams, but this time using Nichols chart. The reason is that both body diagrams and Nichols chart are two methods that are different and yet answer the same problem. Okay, so body diagrams, Nichols charts are two different approaches to answering the same questions. Okay, and so it's really important for you to understand that, because if you look at the definition that are provided for body diagrams, you will see that it is very similar to the definition that I give you for Nichols charts. Okay, and the reason for that is because both body diagrams and Nichols charts are used to answer the same question. It's just two different ways of solving the same problem, and it's really important for you to understand that. And so what do we do in Nichols chart? We are basically plotting the gains versus the phases, and the points that we obtain will each correspond to a frequency value. Okay, and I am going to illustrate that with a short, quick example. Let's say you get a table like this, and as you can see in this table, you have frequencies. One frequency is 15, the other frequency is 20. Okay, and then you have magnitudes. Okay, you will remember in the presentation on body diagrams, we referred to the magnitude in decibels as gain A. Okay, but in this module, sometimes you will just see that the right magnitude. What is important for you is to look at the unit in brackets. Once you see the unit in decibels, you know what it is. And the same applies to the phase, okay? When we did body diagrams, we sometimes used the Greek letter theta to refer to the phase, but in this module, sometimes they will just say phase. But what will give it away is that the unit is in degrees. Then you know you're dealing with the phase. And the frequency, of course, we know is in radians per second. So you have this table here that is given to you, and you have these values. So now, how do you plot them on the Nichols chart? How do you plot these values on Nichols chart? Again, I will remind you that Nichols chart is essentially a plot of gains versus phases, meaning on the x-axis you have phases and on the y-axis you have gains. And so you will plot those gains against the phases, and then each point that you will obtain will correspond to a frequency. Okay, so let's do that quickly. So this is the graph that you will be given, the graph paper that you will be given. Okay, it's called Nichols chart, and it is on this that you will actually do your plotting. And as I said to you, that we're plotting gains against phases. And so in this case here, if you look, for instance, at this frequency of 15, the gain that you have is 28 and the phase is minus 70 degrees. So we're plotting gains versus phases. So this is what we are interested in order for us to plot the point. And so on the x-axis here, you have the phases, and on the y-axis, you have the magnitudes. Okay, and so when I say magnitudes, okay, it's the gains. Okay, but in this module it will very frequently be referred to as magnitudes. And so on the y-axis we have magnitudes, on the horizontal we have phases, and the values are repeated also here on the right and there on top, but it's the same values. And so now we have to plot the point that's got a phase of minus 70 degrees and a magnitude of 28. Okay, so if you look at that here, this is minus 30 degrees, minus 60, and this is minus 90. And so if this is minus 60, this is minus 90, then minus 70 is somewhere on this line. Okay, it's on this line here. Okay, that's where you have minus 70. Okay, so all the minus 70 degree phases will be on that vertical line. Okay, and so minus 70 is here, so that's the phase. We've located the place for the phase, but now that must intersect with a magnitude of 28. Now the magnitudes are on this axis. 28, this is 25, that's 30, so 28 is somewhere here, because you can see it's divided in 5 squares. So that's 25, 26, 27, and this here should be 28. So we need to go and meet that minus 70 degree line, which is somewhere here. Okay, so if you come from 28, you meet the minus 70, you are at this point over there. Okay, and so we can plot that point and you will see there it is. This is the point that corresponds to a magnitude of 28 and a phase of minus 70 degrees. And so once you've plotted that point, this point corresponds to a frequency value of 15. So what you do then, you write there that the frequency is 15, because you can see when the frequency is 15, we have a gain of 28 and a phase of minus 70 degrees. Now on Nichols plot, what we are doing, we're plotting gains against phases. Okay, and so this is what we are interested in. But once we found our point, this point will then correspond to that frequency. Okay, and so in this case it's a frequency of 15 radians per second. And we can do the same thing for the second point here, where the magnitude is 17 and the phase is minus 110. And if we plot it carefully, we will find it to be here, because if you look here, the magnitude that you have, this is 15, so that's 16, and there is 17. And if you look at the phase, this is minus 90. Okay, so that will be minus 100, and here minus 110, because this is minus 120. And when the two meet, where the two meet, that is where you will have the point. Okay, and so this point here will therefore correspond to a frequency value of 20 radians per second. That is what it is. And so we've plotted those 2 points. Now, if we connect those 2 points with a line like that, this line is what we refer to as the open loop gain versus phase curve. Okay, this is the open loop gain versus phase curve. Sometimes they may even refer to it just as the open loop gain curve. Okay, but it is also called Nichols plot. So if you come across the expression Nichols plot, do not be alarmed. You know it is just that curve that joins all of those points. Okay, as I just demonstrated to you now. Now, what is really important for you to see at this point is that on Nichols chart, you have open loop gain values and open loop phase values, and those are the ones that you see on the horizontal and the vertical. Okay, on the vertical axis, what you have are the open loop gain values. On the horizontal axis, what you have are the open loop phase values. And so when you're doing an open loop curve plot, then you look at those axes, okay, the horizontal and the vertical. But as you can